Okay, now we're recording. And once again, I'm going to share my screen. All right. And this time we're going to go to, you said practice test 17, as I recall?
Yes.
All right, so. Yeah, you are guaranteed not to be the only person to ask about this.
Okay, good.
This
That always makes me feel a little better.
Well, this is the one that hangs people up. And we did one like this in class. In fact, we might have even done, I don't know. But anyway, here we go. So I've got the table, only it's not at the left, it's up on the top.
Okay, so you have to break it down, all the possibilities.
Yeah, when it says find all the implications, first of all, you remember what an implication is, right?
Right. That's when it's a tautology, it implies.
And it's an if-then.
Yes.
So what I have to do is take the A, the B, and the C and try all the different ways I could if-then them.
Okay, that's what I wasn't sure about.
Yeah. So do you see how I tried if A, then B, if A, then C? So then I started the ones that begin with B. If B, then C, if B, then A. By the way, you don't have to do if A, then A. That doesn't make any sense. Okay. And then lastly, if C, then A, and if C, then B. And given the truth values over here on the left, you can actually, do you get how I figured these out? So yes. Like, if A, then B. If true, then true. That's true. The only time an if then is false is when the first one's true and the second one's false.
Mm-hmm.
So the second line is false.
So we can stop there.
I didn't do any more in that column.
Right.
Because it's got to be a tautology, so that's a failure. Well, you can see that 3 of them did turn out to be tautologies. The ones that I put a red asterisk by.
Mm-hmm.
And so here's my answer down here in the corner. Okay, because if B then C is a tautology, that means B implies C. Likewise, B implies A, and C implies A.
Okay, that makes sense.
But I can almost, even though we don't have anybody else on right now, I'll bet I get 2 or 3 more of the same problem question. I
thought part of me is like, that must be what they want, but then another part of me is like, wow, this is an awful lot to try to, to figure out.
Yeah, this is a big problem. That is true. Yes. Okay. Your next question was what? Practice test 24.
Yes.
So here's 24. It says supply a valid conclusion using all 3 of these premises. Okay, so I copied them down over here on the left. That's just a copy of what's up here in the problem.
Okay.
Well, these are all if-thens, and we got to get them to chain. They don't chain. So we got to do something different. So what I did is I took this second one, and I wrote it. I did the the contrapositive?
Right.
And that gave me if R then P. Oh, so I could stick that up on top. See how I put that up on top then?
Sure.
And then we can follow it with the one that was first. So the P's chain. And then I did another contrapositive right here. And sure enough, that fits in on the bottom. And now look at, they all chain. So now if R, then not S.
Okay.
So there's a case where, okay, they're all if-thens. You're supposed to find a conclusion. You got to chain them. And you can't, and when you can't chain them, you got to try some things I taught you to rearrange them so that some things connect.
Right, because I wasn't thinking the contrapositive or anything like that. That's
Yeah.
I was thinking it.
Yep. And then related to it, I put this thing in on the bottom here. I see I should have made that bigger, but it's not going to help. We can't get it. Anyway, these are all things. Don't forget about the contrapositive. Do you remember this one in the red box here?
Right, that one yes.
Okay. And then here, this one on the bottom is just an alteration of this one in the red box. It says, well, what if the first number is not a knot? Well, what do you do here? If it's not P, what did we made it into a regular P. So if it's P, guess what? We make it into a not P.
Okay.
So this is like, what would you call it? You know, a little alteration of the rule I taught you. Does that make sense, that last line there?
It is. Can you just
Okay.
leave it up for just a second?
Yep, I sure will. And then I am going, when you're done with that, I'm going to go back and see if we have anybody joining us. So really the question was over up here. Above the red line, that was the question. That was the test question. This stuff down below is just extra teaching tips.
So I think like number 25 I had a question on, and I think it's the same concept. I think I just have to remember the switching.
So I'll tell you what, I'm not skipping that. I just think I got it because it's just about time. I'm going to go back. I still got 25 on my list.
Oh, okay. Go ahead.
Okay. Did you get your info?
Yes, I did. Thank you.
Okay. Still nobody else live. Got 2 minutes until we begin here. And we did your 3-2 problems also. I got a couple 3-6 questions, and I've got 4 more test questions that people have asked about. And hopefully we'll get more. So if anybody else out there is connected but not live, please send me your questions by text message, or if you want to go to the chat window, if you move your cursor off to the left, up in the top left corner, there's a little blue thing. And if you open that, there's a chat window that opens up on the right side of your window. And if you'd rather not speak, you can send me questions over there. Right now I am typing a message in that system, which just says welcome. So that's, and then of course you can still phone me, 262-510-2046 for text messages. We do have a nice live connection with Michelle. So I'm hoping more of you come in that way.
Yes, I will. So this rule where we negate,
Yes.
if then, okay, so if it's an if then, and then we can change it to an or if we negate the first. Is that correct? The first.
Yeah, correct. If P then Q is totally equivalent to, not P inclusive or Q.
And then the same way, P or Q is equivalent to not P then Q.
That's correct.
Okay.
And that can come in handy when you're doing a problem like that, those chain reaction ones or of that type. Okay, anybody out there with questions? I'm collecting them. I've got more from, we went through a few already on video, and we even did a couple before I started the video, because she was here nice and early. I've also got, these test questions have been asked about that we haven't done yet. Number 2, number 6, number 12, and number 25. And then I've got 2 questions from 3.6 that have been requested in. I see Mike. I just got a message from Mike. He's logging in from work today. Hi, Mike. I guess I better answer him too with text. Okay. Still taking questions, just for a couple more minutes, and then I'm going to start diving into the list that I currently have. Okay, send those text messages. I am going to start with lesson 3.6. Number 25, which I believe was requested by Gumi. Okay, so I'm going to go back to sharing my screen. You guys are seeing a different piece of software, just so you know. I basically lost my entire computer 2 days ago. And my life is on there, so it's been a lot of hustling trying to get things ready for today. And this little experiment I'm trying, which is a different program, actually is working quite well so far. Let's see if it continues. All right, so right now I'm going to go to number 3.6. Let's see if I have that one. 3.6, number 25. I do. Okay, Gumi, this is the one you asked about. 3.6, number 25. Let me get to the right page. So it looks like this is a chain reaction problem, isn't it? Yeah. Got to find the page here. Okay, it's on page 165. All right. So, grab the pen. So, page 165. What's on the left there is what was given. If P, then Q. If Q, then R. If not S, then not R. And then there's that sole P, which I don't know if you remember from class, but I called that a trigger. So what you do is you try to get the 3 if-then statements in a sequence that chains together. Well, the first 2 already chain together. If P, then Q. If Q, then R. The Q's chain real nicely, so just leave those be. But the last statement does not chain. So what could we do? Michelle, could you offer that for us? What could we do with this if not S, then not R there?
We could make it an or, but
we could, but because this is a chain reaction,
we could do a contrapositive.
Right on the money. Yep, she's right. You could do an or too, but in this case, we really need the if then. So I changed it around and I negated them both, and we have if R then S. Now look at the R's chain. Beautiful. We've got a chain reaction. I know I'm not forgetting this P over here. But now we can draw a conclusion from these 3. The Q's chain, the R's chain. So therefore, if P, then S. So we've got kind of an intermediary conclusion. Now bring in the P. If P, then S. And if you have a P, the final conclusion you're going to get is S. So Gumi, you're not on live. Hopefully that makes sense to you. I know you asked about that. So that's 3-6, number 25. Let's see, do I have 3-6, number 29? I don't, so we're going to add that. All right? So I'm going to move this thing, and we're going to add 3-9 here. This is another little experiment. Let's see, let's turn that off. Let's go with blue. Okay, so this is 3.6. Number 29, and I'm going to move my keyboard here, change things around so I can write a little bit better. Okay, number 29. Find valid conclusions. All politicians run for office. So in other words, if you're a politician, then you run for office. Is it okay if I abbreviate it that way? So if you're a politician, then you run for office. No people who run for office are reliable. So doesn't that really say if you run for office, then you're not reliable? So if you run for office, whoa. Let's try cleaning that up a little bit. Okay. Getting used to these new tools, guys. If you run for office, then you are not reliable. I'll use, should I say, RE for reliable? Can you draw a valid conclusion? Well, do you notice this is kind of cool? We have, here, let me change to red. We do have a chain reaction, don't we? The ROs nicely link. So can't we draw a conclusion here? If P, then not RE. You get what that is in text? If you're a politician, then you are not reliable. And that is the conclusion that comes from those premises. Wow, I just made a strong statement against politicians, didn't I? So Gumi, again, I hope that answers your question. That was 3-6, number 29. Now, the remaining questions that people have given to me are on the practice test. So now I'm going to go to the practice test. You can still send me questions. I'm just going with what I currently have in hand here. Practice test number 2. Okay, there's the practice test. Oh, I don't have that one. Okay, we'll do that one. And I got to go back here. Oh, I see that got moved a little bit, didn't it? Interesting. Okay, do you think you can read? Here, let's blow this up a little bit. Okay, practice test number 2. I think you can all see it. I just got a text message. Let me quick check. Yep, Gumi got it. Looks good. All right. So, you can all read number 2. It's right here. Whoa, got the wrong tool. Read it. Let's see. I got to get rid of the file. I got to get my red pen back. Okay. So we're taking a look at number 2. Identify the components and the logical connective or modifier in each of the following statements. hopefully, here, let me blow it up a little bit more. There we go. I think everybody can see it probably. Michelle, is everything still nice and visible for you?
It's very good, thank you.
Okay, good. All right, so A, if the number of a year is divisible by 4, which they're abbreviating as D, then the year is the presidential year, is a presidential year, P. So that's just if D, then P. So you would just write, so all they want you to do is take the letters that they suggested and connect them with the proper connection. And in this case, it's an if-then, so we had to use the arrow. Part B, I love Bill, but Bill does not love me. So now we got B, I love Bill is B, Bill does not love me, not M. Uh-oh. What do we do with the word but, B-U-T?
Isn't that an and?
Yep, exactly. So really all we have is I love Bill and that's supposed to be a not M. Let's, I'm trying to type on the screen without leaning on it and not doing so well. So, build it, and unfortunately, he does not love me. Okay, and part C, a candidate is elected President of the United States if and only if he or she receives the majority of electoral college votes, M. You guys remember what this, what do we do when we have an if and only if? That's this connector. The double-headed arrow, that's, I know it's a biconditional, but it's also, it goes with those words if and only if. Now, because this one goes both ways, it really doesn't matter. I'm going to put M here and E here. But that one could be reversed. E and M could be on either side. By the way, this second one here, B and not M, that one could be reversed too because and is bidirectional. But that first one, if D then P, cannot be reversed. Okay, what's part D? Janet can make sense out of symbolic logic or fail this course. Well, that one's just pretty clear. It's just S or F. And finally, Janet cannot make sense out of symbolic logic. That's just not S. There's not much to do there. So 2 was a question asking to see if you get your symbols and you know how to put them together as a translation of an English sentence. So that was practice test number 2. All right. Next one I got was practice test number 6. Let me try to get there. Okay, here's number 6. Write the negation of each of the following statements. If Joey does not study, he will fail this course. So how do you negate? This is a big one. A is one that might be a tough one for students. How does one negate an if? By the way, do all of you see that A is an if-then statement? Even though the word then is not there, it says if Joey does not study, then he will fail this course. The word then is implied. How do you negate an if-then? You keep the first part true. Remember, what's the only line in an if-then statement that's false? When the first statement is true and the second statement is false. So I left the first one exactly as it was. That's what I mean by true. I left it alone. And then I negated the second part. Do you see that? So if Joey does not study, he won't fail this course. So that one was a little bit tricky.
So you said negating an if-then You keep the first part true and you negate the second. Is that what
Right.
you? Okay.
Yeah, that's exactly right. And that's because the only line in an if-then truth table that's false is when the first statement's true and the second statement's false. Okay, and part B, if Sally studies hard, then she will make an A in this course. Same thing. How do you negate that? Keep the first part true. By the way, I could have said, if Sally studies hard, then she doesn't make an A in this course. Or instead of using then, I used and that works too. Anybody else want to talk about this one a little bit? Number 6 on the practice test. So this is a challenging problem because, I don't know, just remembering that if-then thing, that the only time an if-then statement is false is when the first is true and the second is false. So therefore, if you want to negate an if-then, keep the first part the same and negate the second part. That'll be a negation then. All right, then the next one that's been requested is practice test number 12. Practice test number 12. Okay, is the following true or false? If 2 plus 2 equals 5, then 2 times 3 equals 6. You notice what I wrote in there? Obviously, 2 plus 2 equals 5 is a false statement. 2 times 3 equals 6 is a true statement. How do you evaluate an if-then statement if the if part is false and the then part is true? Remember that? Ironic, whenever an if-then statement begins with a false, it's guaranteed to be true. If you just go back and check your if-then truth table, you will see that it's got to be that way. Any discussion? Feedback? I'm just checking for questions. I'm not getting much feedback from you guys today, except for Michelle, who's connected.
Par for the course.
What's that?
Oh, I just said it was par for the course. I seem to always have a lot of questions.
Well, that's great. That's what I want. And yeah, and you sent me some too. Okay, so I just did 12, so we have one more, Michelle, and that's the one you asked about, number 25. All right, so practice test number 25 coming up, if I can find it. Okay, it says construct a switching network to represent the statement. Okay. Of course, here's the problem. I never showed you how to do if-then statements for switching networks. Now, Michelle and I were talking about this at the beginning of class. You guys remember what's in the box here? What's in the box, we've talked about several times. I think it started off as a hint in the textbook in one of the assignments. If you don't know what's in the box, you're not going to be able to do this problem. So those two are totally equivalent. I should have just said that. If P then Q is equivalent to not P or inclusive or Q. So because of this, I can substitute one for the other. So I don't know how to draw a network for an if-then, but I can translate that to not P or Q. And this one, I can likewise translate. How do I translate that one? Well, you keep the second letter the same, right? Q, Q, but the first letter, I have to negate it. And then change it to an OR. All right, now that I have ORs and ANDs, I can draw the network. How do you draw an OR? Remember, that's a stack. P over Q, except it's a not P, so we have the apostrophe. And here's a stack, P stacked with Q prime. And then those two stacks, because we have an AND, are side by side. Just put a beginning and an ending on it. And we've got our diagram. Now, this problem, if I put this on the test, I might have made it extra credit, because this knowing what's in the box here is what? Just maybe a little bit over the top? I don't know. So this might have been an extra credit if it was on my test. So it's a pretty challenging one. Without that, we couldn't have done anything. Okay, I got a message coming through here. 24 on the practice test. Will do. I had done that with Michelle earlier, but we're going to go back and do it again. Michelle, did that answer your 25?
Yes, that's exactly what I thought I was doing wrong. Okay. I figured there was some code I was missing.
Yeah. And so let me just go to number 24, practice test 24. And then I got test number 17, I think from Rhonda. Okay, we had done that one too. Okay, Michelle and I worked through some of these earlier, but we'll go back and look at them. I'm going to go back to 17 first. Okay, I told you, Michelle, somebody was going to ask about this one.
Yes.
Okay, here's 17, along with all my stuff. Okay, the table, it says the table's at the left. Well, it's up above. I pasted it up on top. You've got these three statements, A, B, and C, along with their given truth values in columns that are 4 high. And you're supposed to find all the implications among these three statements. So the big question is immediately, what is an implication? An implication is an if-then statement that results in a tautology. So because it's an if-then statement, what I need to do is find I've got to imagine all the possible if-thens given the three letters A, B, and C. So way at the top there, you see how I did, all right, let's do A, B for if A, then B, and how about if A, then C? So in other words, I stuck with the A's first, and got those out of the way. Then let's start with B, if B, then C, if B, then A, and then I'll start with C, if C, then A, if C, then B. And then I just went through using this little table over here and found the truth values. So look at the first one, if A, then B. So if true, then true. That's true. But the second line, if true, then false, that's a false. So as I write this false down, you notice I quit. I didn't go any further because for there to be any good here, I got to get a tautology. So I'm out of luck on that one. Second row, the second column, I struck out on the last one. Well, in this one over here, I struck out on the second one down. Notice these three, I struck it rich. I found 3 implications. And so my answer down here on the bottom, because if B then C turned out to a tautology, I wrote here B implies C. Do you remember that symbol for implies? And B implies A, and C implies A. So I think that was you, Rhonda. Let me know if you want to follow up on that at all. I'll leave it up there. There's a lot of writing there, and you probably want to, I don't know, you might be taking a few notes. Okay. Hopefully you've had enough time. I'm going to go on to Number 24 on the practice test. I'm looking. I got 4 new messages. Can you please do 24? Yep, here we go with 24. Okay, I don't know. I've lost track of who's asking what, but anyway, practice test number 24. Okay? All right. If I knew how to use the cover-up shade, I would cover up this thing below the red line, but I'm too new with this. I don't know how to do that at the moment. Maybe I do, but I don't want to mess with it. All right, so here's the problem up here on the top. Supply a valid conclusion using all 3 premises. 1, if P then Q. 2, if not P then not R. And 3, if S then not Q. I wrote them all in the circle on the left up here. Okay? The only way to draw a conclusion from 3 if-then statements is to chain them, and nothing changed at the current time. Nothing. All right? So, well, I looked at these ones with the knots, and I thought, you know, we could maybe do a contrapositive, and not only would that turn that around, that would take the knots off. So this second one right here, I wrote the contrapositive of it right here. If R then P. Well, it still doesn't chain, but it looks better. And I wrote the contrapositive of this bottom one too. But look at, if I rearrange, if I take this if R then P and stick it up on the top over here on the far right, and if I take the top one that was the top and move it in the middle, bingo! Look at the P's chain, the Q's chain, and wow, I've got a chain reaction. And now it's pretty easy. If R, then not S. So that was one of those problems where the chain wasn't there until you used some of your rewriting skills. Now both of these were done with contrapositives. Now down below, so that's the end of my advice for number 24, but down below the red line, I've got some other things for you to remember in the box. We've already used this one. You can take any if-then statement and rewrite it using a contrapositive. We did that twice up at the top. Number 2, don't forget this one. We just used it before. If you do have an or, you could use this little clever idea to rewrite it so that it is an if-then. Remember, we used it the opposite way. In the diagram problem, we took an if-then and turned it into an or, but you can take an or and turn it into an if-then. And in the case of a chain reaction problem, that might be just the ticket. So, yeah. Oh, and then this bottom one is just saying to you, hey, what if the first one's not a not? That's okay. How do you rewrite these ors into if-thens? You replace the or with an if with an arrow, and the second letter stays the same. And then what do you do with the first letter? You just negate it. So not P becomes, P becomes not P. So, however you can remember that, I'm using the words that work in my head to remember that. All right, so there's number 24. Did we do 25 already, Michelle?
We did, yes.
Is there anybody else who did not see, or did I just do that a few minutes ago? I think I did. I've done it a couple times, but I don't know if everybody who asked has seen it. Anyway, of course the video will tell all, but the only thing, Michelle and I did a couple problems. She was in nice and early, so we did a couple before I started recording, but I think now we've gone over them. Michelle asked me a couple questions on 3.6 that I think we went over before we put on video. Okay, what's next? Thanks for the good questions, everybody. 23. 23 on test. Rhonda, got it. 23 on test. Okay, that's next. Practice test 23. Okay, here we are. Use a truth table to check the validity of the following argument. If you win the race, then you're a good runner. You win the race. Therefore, you are a good runner. This must be about Michelle, the runner. Anyway, so I abbreviated it. If you win the race, then you are a good runner. So I just wrote if W, then R. And then we've given that you win the race, so we've got a W for a second premise. And the conclusion is, must be R. Is that a valid conclusion? Well, using a truth table, good news, we only have two letters, W and R. So we set up our four-table truth table. Some students forget to do this. This is really big for me. You need to make sure you have a column for each of the premises. You know, this is premise 1 right here. This is premise 2. And this is the conclusion. You need to have a column for each of those. So, all right, first premise, if W then R. Second premise, W, conclusion R. Okay. Standard truth table. Go through the rules. Circle all the rows where all the premises are true. Well, in this case, we have what? Two premises. There is only one line, the top one, where both the premises are true. So now all you need to do is check, are there any false conclusions in the circles? And there are not. Therefore, this is a valid argument, and we used a truth table to see that. Questions? Any more? Let me know if I missed any. I've been trying to write them down. I think we've got them covered, the ones that I've been asked so far. And I'm watching my phone here for other text messages. Just a reminder, because we don't see each other very much, you know, when we get there on Wednesday night, I'll take some time for questions and just make sure we can solidify whatever, you know, just try to be a little more sure, see if there's any questions that are unanswered yet. So we will do that Wednesday night, and then we'll go into the test. Questions? So it's kind of quiet here, both on the text message side and they're just not getting any questions. So what I'm going to do then, I'll wait a few more minutes, but you can still send me questions, and I can send you some nice detailed advice and solutions by email. So don't hesitate. You can ask me anytime. You don't have to keep your questions to this session. Anytime is just fine. I'm gonna stop sharing, and we'll try to see if I can get my keyboard back here. Okay. Hi Andrew. How you doing? At least Andrew's picture there.
I'm here.
Yeah. Did you have any questions, Andrew?
No, I'm all good. Just following along.
Okay, that's good. Thanks.
Yep, thank you.
Anybody else questions? Otherwise, I am going to sign off for now, and contact me. Be happy to work with you.
I'm good.
Thanks so much for participation, Michelle. Thanks, Andrew. Thanks, Rhonda. Thanks, Mike. Thanks, everybody. I can't remember. Gumi. We had good questions from a bunch of people. Have a good rest of your Sunday. And let's hope the Packers get things going today. Go Pack, go. By the way, research T-shirt. Good evening, everyone. I'll see you.
See you Wednesday.